So we're going to talk about rational functions. And rational functions is just, you know, we've been looking at linear equations. We've been looking at quadratic equations and different polynomials. This one's called a rational function. And basically, in a little bit, you'll see how it looks. Let me get my pen. So one of the first things we want to do is to look at how a rational function is set up. And basically, it's a polynomial divided by another polynomial. And the domain is going to be all real numbers except for those that cause the denominator to be 0. So previously, we talked about finding the domain. And one of the questions we asked was, if it has a fraction, what are the numbers that would cause it to be 0? So if you remember from class, we said that we would take the denominator and we would set it equal to 0. And if I solve for x, then this number here cannot be in the domain. Okay, so my domain for this function is going to be everything except for 5. So we can write it as negative infinity to 5 union 5 to infinity. And so for these 3 examples, they are kind of a review of what we have done. Let me just move that down. So if we look at example 2, find a domain. Something we can do here first is factor the polynomial down here. So this is going to factor as, what do we get? So this is going to be 6 times 2 is 12. And I need the 4 to be negative, so this would be a positive here. So if I set each of these equal to 0, then I'm going to have that x cannot be 6 and x cannot be negative 2. So these guys can be in the domain. Okay, so for the domain, we would write it as from negative infinity to negative 2. And so if you can imagine the number line that we did in class before, we have going from negative 2 to negative 2. I'm sorry, negative infinity to negative 2 union negative 2 to positive 6 union 6 to infinity. If any questions?
No.
Okay. So let's try example number 3. So here we have in the denominator, x squared plus 25. If I set it equal to 0, I get x squared equals negative 25. And here, since it has a negative, if we take the square root, then this becomes 5i, plus or minus 5i. So this is an imaginary number. And so when you get an imaginary number, there's really no number that you can put in here that's going to cause us to get a 0 in the bottom. Because if I use negative 5, it would become a positive 25 plus 25 would be 50. So we're okay there. So there's really no number that can be excluded from the domain. So the domain would still be negative infinity to positive infinity. So it's really only the numbers that cause you to get 0 in the denominator. So that is a review from one of our previous sections, is just finding the domain. But just like any section, we want to know, what does it look like? What does this function look like? So if I draw a table here for my x and y, I can use some negative numbers. 0, notice I have x down here. I cannot use 0. So I'm going to skip 0. And if I evaluate the function at negative 2, I'm going to end up with negative 1/2. If I evaluate it for negative 1, I end up with negative 1. If I evaluate it for 1, I get 1. And for 2, I get 1/2. So if I plot these points, Then we have -2.5, which is right here, -1 and -1, 1 and 1, and 2.5. So far it's only 4 dots, but the graph for this is going to extend this way, and then it's going to go down this way, and then it's going to extend to this side and this side. But the graph is never going to cross the x-axis here or the y-axis. Okay, and so that is the basic form. This function is also called the reciprocal function. So anything that looks like a rational function will have a similar shape or similar type of a graph. So that is the way it looks like. Any questions on the graph? The reason these graphs do not touch the x-axis or the y-axis here is because they're called asymptotes. And so in the next page, hopefully you guys have your notebook. On the next page, we're going to be looking at vertical and horizontal and slant asymptotes. And basically a vertical asymptote is a line where the graph is not going to, it's going to get really, really close, but it's not going to touch it. It's not going to reach it. And a horizontal is the same, but it's going to be a horizontal line. And then the slant one is going to be a little bit different, which we'll talk about when we get there in a second. So for example, 5, it says find all the vertical and horizontal slants. And these slants, you can see them with these dotted lines. So let's do the vertical ones first. So here I have a vertical line, and that is passing at x equals 2. So that would be my vertical asymptote. Horizontal asymptote is going to be this dotted line here, which passes at y equals 1. And so those are the asymptotes for that graph. For this one, for the vertical asymptotes, we have this line here, which is at x equals 2. And then we have this line here, which is at x equals -2. And then the horizontal asymptote, if you notice, you don't see any dotted line that is horizontal. However, notice that the behavior of this graph is getting really, really close, but it's not going to cross over that x-axis. So there is a horizontal asymptote, and it's at y equals 0. So at y equals 0, the graph is not going to cross this x-axis. And then for the third graph, you don't see any horizontal or vertical dotted lines. This is going to have what we call a slant asymptote. And a slant asymptote is basically a asymptote, and the equation for that is y is equal to x. So it's this line right here. It's a linear equation at y equals x. Okay. Now our goal for, go ahead.
No, I was just saying, yeah.
Okay. So our goal for this section really is how do we find these dotted lines? That is the important thing, that one of the important things that we want to do. So first we'll work with the vertical asymptotes. So to find them, there's really 2 steps. The first one is you want to factor the numerator and the denominator completely. Okay. And once you factor, you want to cancel any like factors. And I'll give you some examples here in a second. And then number 2, what we want to do is we're going to be setting the denominator equal to 0, kind of like the way we found the domain. But first we have to cancel any like terms. and solve for the variable. Okay, so those are our 2 steps. So let me do an example with those 2 steps. So it says find the vertical asymptote, if any, for each graph. So the first thing is to factor the numerator. So here, x is already factored, but x squared minus 1, we can factor as x minus 1, x plus 1. And then you want to ask yourself, can you cancel anything here? And we can't. The only time you can cancel something is if we had, for example, something like this, then we would be able to cancel the x plus 1. But in this example, we only have x up here, so we cannot cancel. So it's already done for us there. So step 2, set the denominator equal to 0. So set denominator equal to 0. So we're going to have x minus 1, x plus 1 equal to 0. And you want to solve for x. So for this one, we get x equals -1, and for this side, we get x equals 1. So these 2 are going to be our vertical asymptotes. And so when later we're going to need to graph this, to graph it, you would just come to the graph, and at x equals 1, you're going to draw it with a dotted line, and at x equals -1, we would draw it with a dotted line as well. Okay, any questions on that one? Okay, so if we go to B, we make sure that it's factored already. So x minus 1 is factored, but x squared minus 1, we can factor it as x minus 1, x plus 1. And then we ask ourselves, can we cancel any like terms? So here, I can cancel this term. Okay. And so I'm left with, after canceling, I'm left with g of x is equal to 1 over x plus 1. Okay, so now we can set the denominator equal to 0. So x is equal to -1. This is your vertical asymptote. Okay, so again, the first step is factor completely, which I did here. Second step, or it's still part of the first step, cancel any like terms, which I did here. And then the second step is set the denominator equal to 0. And so we get x equals -1. That's a vertical asymptote. Now, anytime that you can cancel a factor, what we say is that it creates a, let me write it here. Okay, it creates a hole in the graph. And what I mean by that is if I had a graph, for example, and I have my graph like this, it's that open circle, that's gonna be the hole. And so you only get one of those if you cancel a term. And so the way we're gonna find it, let me write the instructions here. Okay, so to find the hole, we're going to set the canceled factor. Set the canceled factor equal to 0. And solve for x. So in this example, our canceled factor was x minus 1. So I'm going to set it equal to 0. So this is where the hole appears. okay? But we want to know the exact location on the graph, so we need to find out, since we already know what x is, we need to find out what y is. So to find y, I'm going to come here. Let me just come over here on this side. So to find y, we take our function after we cancel the factors. So remember up here, this is what we have had left. So we plug it in here as our function. And since x is equal to 1, we're going to substitute the 1 for x. So we get a half. So the whole is going to be at 1.5. So whenever you draw your graph, for example, here's 1 and here's a half. The graph would have a open circle at that point. Okay, so the next example is also going to give us a chance to practice finding that whole if it has one. Any questions on this example? Okay, so let's look at letter C. And if you notice, letter C and D is the same example. So I'm just going to work out the C one over here. And so again, the first thing is we're looking for a vertical asymptote. And so I need to factor this vertical asymptote. Does it factor? So x squared plus 1 is not going to factor. So this is already set. So if we go x squared plus 1 is equal to 0, and I take the square root, I end up with an imaginary solution. And so whenever that happens, we say that there's no horizontal asymptote. Okay. But let me give you one where we can practice finding everything else again. So this is an extra example that's not in your notebook. Okay, so let's say we have f of x is equal to x squared minus 4 divided by x minus 2. So the first step is to factor this completely. So the top part is going to factor as x minus 2, x plus 2. So that is how the numerator factors. And then the denominator is already factored. And can I cancel out any terms? And if so, what can I cancel out? Anybody want to share what they think?
I have no idea.
So which ones are common? So the x minus 2 and the x minus 2, they're the same, right?
Mm-hmm.
So those we can cancel. And so what we have left is going to be x plus 2 on the numerator. And on the denominator, there's nothing left, so there's only a 1. So our new function here is x plus 2. So after we cancel, the next step was set your denominator equal to 0, but there's no more denominator here. Notice how the denominator is not there anymore. Like in these examples, after we canceled, we were still left with a denominator. But on this one, there's no denominator. So what that means is that there's no vertical asymptote because we have no denominator left, okay? However, since you were able to cancel this term here, then there exists a hole in the graph. Okay, and so to find it, we do the following. Number 1, set the denominator, set the set the cancel term equal to 0. So our cancel term here was the one that we scratched out over here. That's x minus 2 is equal to 0. So if I solve for x, I get x equals 2. But then we need to find a y for that. Okay, so to find the y, we're going to plug it into what we have left after we canceled the terms. So we're going to plug it into f of x equals x plus 2. So what this means is that there's a hole located at 2, 4. So on the exam, I don't believe that the questions that I selected don't ask you to find the hole. But in case it did, this is what the steps would be. But if I remember correctly, I didn't choose any that asked you to do that. So that is how we find the vertical asymptote. Now we want to find the horizontal asymptote. So let me go to the handout. To find the horizontal one, it has 3 different cases or situations that could occur. So the first one is if the degree of the numerator and we're going to call this n for numerator, is less than the degree of the denominator, and let's call that m, then there is a horizontal asymptote at y equals 0, which is the x-axis. Okay, so this is what I mean by this statement. Let's say you have a function f of x, and you have x plus 1 divided by x squared plus 2. Okay. To find the horizontal asymptote, we need to look at the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then it's going to automatically have an asymptote at y equals 0. So the degree of x here is 1, and the degree of x here is 2. So the degree here of the numerator is 1, and the degree of denominator is 2. Okay, so the top one is smaller than the bottom one. So the numerator is smaller than the degree of the denominator. So automatically we say that this problem will have a horizontal asymptote at y equals 0. And that's going to happen all the time. So for example, if you had f of x equals x cubed minus 3 divided by x to the 4th plus x squared plus x plus 8, something like this. If you want to find the degree of the horizontal asymptotes, we have to check the degrees here. Well, the numerator is smaller than the denominator, okay? So if that's the case, then we say that there's a horizontal asymptote at y equals 0. And it's always going to be y equals 0 if this is smaller than this one, okay? And we'll do some examples right now. The second case is when they're equal. If degree of numerator equals degree of denominator. Okay, if that happens, then the line y equals the leading coefficient of numerator divided by leading coefficient of denominator. So let me tell you what I mean by that. That's going to be your horizontal asymptote. So for example, if I had f of x is equal to 3x divided by x plus 4, we check the degrees. So this degree is a 1 and this degree is a 1. So the degree is the same, okay? So degree is the same. If that happens, then to find your horizontal asymptote, we would do the following. We would say y is going to be equal to the leading coefficient of the numerator. In this case, it's going to be 3, divided by the leading coefficient of the denominator. In this case, it's going to be 1. So y equals 3 would be your horizontal asymptote. And I'm going to give you another example. That way you can try it. Let's say we have 4x squared divided by 5x squared minus 8. Okay. So first, ask yourself to look at the degrees. So the degree here is a 2 and a 2. So they are the same. So that's going to be option number 2. If the degrees are the same, then the horizontal asymptote is y equals the leading coefficient divided by the leading coefficient. So in this case, they're the same. So y is going to be equal to the leading coefficient of my numerator here is 4 divided by my leading coefficient of my denominator, which is 5. So this is going to be my horizontal asymptote. So when you draw your graph, for fifths, you would draw a dotted line that is a horizontal line. Okay, so that is the second case. The third case is if the degree of numerator is greater than degree of denominator, then what we're going to have is that there is no horizontal asymptote. Okay. So the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. For example, if I had f of x is equal to 3x squared divided by x plus 1, my degree here is a 2, and this one has a 1. So the degree of the numerator is greater than the degree of the denominator. So my answer here is there's no horizontal asymptote. Okay. And let me add to that statement here. So if there's no horizontal, then there might exist a slant asymptote. And the way we know if there's a slant asymptote is as follows. If the degree of numerator is 1 more than degree of denominator, then that's how you know if it's going to have a slant asymptote. Okay, So let me give you a couple of examples, or let's do the ones from the handout, and then I'll add some more if needed. So here it says, find the horizontal asymptote of each rational function. So to find the horizontal asymptotes, again, we're looking at the degrees. So for this one, the degree is, we have 9x squared divided by 3x squared plus 1. So the degree of the numerator is a 2, and the degree of the denominator is a 2. So the degrees here are the same. So what we need to do is the horizontal asymptote would be y is equal to the leading coefficient of the numerator, in this case 9, divided by the leading coefficient of the denominator, in this case 3. And so if I simplify this, then we get y is equal to 3 is our horizontal asymptote. Any questions on that?
So for do you just do like what happens to like +1 or the other number that is in the denominator? Does it just not apply at all?
Yeah, so for the horizontal, when you're looking for the horizontal asymptote, then it won't apply. Like, we don't need it for anything at that point. The only things that we need to find the horizontal asymptote is the degree, and then maybe the leading coefficient, which is the 9 and the 3. But
Yeah.
the 1 is kind of just hanging out for a little bit.
Oh, okay. All
It's not useless because we'll need it eventually, but it's, for right now, it's just observing. Okay, so let's look at this one. What is the degree of the numerator?
2? Oh no, 1.
1. So that's a 1. Let me write a 1 here. And then the denominator degree is what?
2.
A 2. Okay, so the numerator is less than the denominator. So let's look at our conditions. That would be statement number 1, right? If the degree of the numerator is less than the denominator, then automatically we just say that y equals 0 is your horizontal asymptote. And we don't have to do anything. That's going to happen all the time. But it only happens if the top is smaller than the bottom, as far as degrees. Okay. Now letter C, what is the degree of the numerator?
3.
3, and the bottom degree is
2.
2. So here, this is bigger than the degree of the denominator, so that's going to be number 3. If the degree of the numerator is greater than the denominator, then our answer is simply that there's no horizontal asymptote. Okay. However, let's check if it might have. As soon as you say that there's no horizontal asymptote, then your next step is to check for slant asymptote. Okay. So to check for the slant asymptote, the degree of the top numerator should only be 1 more than the degree of the denominator. So if this is 3 and this is 2, is it 1 more? So 3 is 1 more than the 2, right? So this is going to be slant asymptote does exist. If you had, for example, this example, 9x to the 4th divided by 3x squared plus 1. So this is a separate example. Then since this is bigger than this one, for sure there's no horizontal asymptote, because that's condition number 3. But to check for the slant one, we have a 4 and we have a 2. So is the number 4 1 more than the number 2?
It's 2 more.
It's 2 more. So since it's more than 1, we say there's no slant asymptote. So it's only going to have a slant one if it's one more.
Oh, okay.
Okay. So let me go to the next page. And we're almost done. I'll do example 8. I'll graph example 9. And then for example 10 and 11, depending on how much time we have left, I'll either cover one or I can do a separate video just for example 10 and 11 that I'll record and upload. But we'll see how we do on time.
Okay.
So here we have find the slant asymptote. Okay. So if you notice, the degree was a 2 and the degree was a 1. And so the 2 is one more than the denominator. That's why we have a slant asymptote. So now they want us to actually find it. And the way we find it is using something that we did in class before, synthetic division. So if I'm going to use synthetic division for this, my coefficients are 2, -5, and 7. And since I'm dividing by x minus 2, I'm going to use 2 as my number that goes on this side. So I bring down the 2. 2 times 2 is 4. -5 plus 4 is -1. 2 times -1 is -2. 7 plus -2 is 5. Okay, so remember that the last number represents your remainder. And what we want here is the slant asymptote is going to be whatever our quotient is. So since we started with something that was x squared, we go with 1 power less. So this would be 2x minus 1. So my slant asymptote is 2x minus 1. Okay, so we use synthetic division there to find that asymptote. Okay, let's see. Questions on that? Okay, let me go to the steps here. So our overall goal is to graph a rational function. And these are the steps that we can use. Number 1, we can find the domain. Number 2, we can plot the y-intercept. So remember to find the y-intercept. This is where we let x equals 0 and solve for y. Okay. We can find the x-intercept, and to find the x-intercept, we let y equals 0 and solve for x. We can find the vertical asymptote. And so after that, we can find the horizontal asymptote if any exists. And I'm going to put here or slant. Okay. And then we can plot at least 1 point or 2 points or as many points as you feel you need to finish seeing what the graph looks like. And you want to do it between the asymptotes and the x-intercepts. So let's look at this example. So I'm going to find the y-intercept first. Okay, so to find the y-intercept, this is the function. So I let x equal 0. So 3 times 0 is 0. 0 minus 2 is -2. So we get 3/2. So your y-intercept is at 0 and 3/2. And we'll plot it in a little bit. The x-intercept, so again, I'm just going to start by writing the function. I let y equal 0. And to solve for x here, I'm going to multiply by x minus 2 on both sides. So we get 3x minus 3 equals to 0. Add the 3, and then divide by 3. So we get 1, 0 as our x-intercept. So those are the intercepts. Then we need to find the asymptotes. So let me check for the vertical asymptotes. So here the function is, okay, so remember to find the vertical asymptotes, it's important that you factor if you're able to. So in this case, I was able to factor a 3 out of the numerator since they had 3 in common. But then even if I do that, I didn't have nothing to cancel. But it's important to do that so that you can check later if you can cancel anything. Since I cannot cancel anything, then your next step is set the denominator equal to 0. So x equals 2 is my vertical asymptote. And then lastly, we're going to find the horizontal or slant asymptote. And I keep writing the equation. It's just easier for me to see it. You can always refer to it up here. So for the horizontal asymptote, this is the one where we're looking at the degrees of the numerator and the degree of the denominator. So they're both 1. So that means that my horizontal asymptote, since they're the same, I just take the leading coefficient of the numerator divided by the leading coefficient of the denominator. So y equals 3 is my horizontal asymptote. Okay, so we plot this information over here. We have 1, 0 is right here. 0 and 3/2 is going to be 1.5, so like maybe right here. And the vertical asymptote is x equals 2. So we draw that with a dotted line. Okay, so that's my horizontal asymptote. Let me use red, maybe it's easier to see red. And then the horizontal one is y equals 3. Okay, so this is what I have here. The dotted lines are the asymptotes, and notice I only have 2 points. And since they're asymptotes, then we know that the graph is going to get closer to this line and closer to this line. So that is what it would look like on this side. But we know that other stuff might be happening, so this is where you want to plot extra points. Okay. We already know everything on this side, so we need to figure out what's on this side. So maybe we can use 1. So if I plug in 1, let's see what do we get. Three minus 3 is 0. 1 minus 2 is -1. So that's a 0. So when x is 1, actually that wasn't a 1, right? We get 0. Let me see where we're at. The point on this side is not a 1, it's actually a 3, because the asymptote here was 2, so this point is a 3. So let's check the 3. So 3 times 3 is 9, minus 3 is 6. 3 minus 2 is 1, so we get 6. So I'm going to go up here, 1, 2, 3, 4, 5, 6. Okay, and then you can plot in more points, or you can just know that since they're asymptotes, the graph is going to get close but not touch. Okay, so any questions on that?
Nope.
Okay, so let me show you, well, I'll show you that in the end. Let me check the time. So I probably could do one more example so that we stay within our time. So let me see which one is a little bit harder. That way I can do the harder one. Let's see. Let me work on number 10. We can do that one. This one doesn't give us a lot of points. Okay, so first let's find the y-intercept. So to find the y-intercept, we let x equal 0. So I'm just going to refer to the function here and not write it every time. That way it saves space. So f of 0 is equal to 2 times 0 squared divided by 0 squared minus 9. So 2 times 0 squared is 0. And we end up with 0. So our horizontal y-intercept is 0, 0. Let's find the x-intercept. So to find the x-intercept, I let y equal 0. If I multiply by x squared minus 9 on both sides, then I get 2x squared is equal to 0. And so if I divide and take the square root, then this is still going to be 0. So my x-intercept is also 0, 0. Vertical asymptote. So for my vertical asymptote, the first step, again, remember, is to factor. So for the denominator, I get x minus 3x plus 3. I cannot cancel anything, so I set each one equal to 0. So x is equal to 3 and x is equal to negative 3. These are my vertical asymptotes. And then the horizontal asymptote. For the horizontal asymptotes, the degrees are the same, 2 and 2. So that's going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. So y equals 2 will be my horizontal asymptote. And so if you notice, if I graph this, I don't have a lot of information. We found this point here, 0, 0 for the x-intercept and the y-intercept. And then my asymptote says that x equals 3. So right here. And x equals negative 3. Right there. And then the horizontal asymptote is y equals 2. And so I only have one dot at one point, and that's it. So what we want to do is figure out some more points. So for example, let's try f of 1. So if I enter 1 here, then here's going to be 1 times 2 is 2. 1 minus 9 is negative 8. So we get negative a fourth. So for 1, we get negative a fourth, which is going to be like somewhere here. And we can try negative 1. So 2 times negative 1 squared divided by negative 1 squared minus 9. So we get 2 minus 8, negative a fourth. So that's going to be about here. Okay. So for this graph, this is going to go down. And then this is going to go down as well. So it's like a parabola in there. But now we need to figure out what's happening on this side and what's happening on this side. So we can choose some more points. The vertical asymptote here was 3. So we can choose, for example, 4. So let's look at f of 4. 4 squared is 16 times 2. It's going to be 32. And then 16 minus 9 is 7. So this is going to be 4 point something, 4.5 or something like that. So whenever x is 4 right here, we get 4 something. So like somewhere up here. Okay. So I know that this graph will get closer to this point here, and then this one will get closer to this point here. And then we can check on the other side, f of -4. Since it's being squared, you're going to get the same answer here. For this one is still the same, 32/7. So this will go down this way. Okay. And so basically, if you want to check your graphs, you can always go to decimals.com. And let me just graph it really quick. This was 2x squared divided by x squared minus 9. And so as you can see, it has the graph, but the only thing that is missing are the asymptotes. So you will not be able to see the asymptotes, but at least it gives you an idea. This is 1, 2, 3. You can see the graph is getting closer and closer to the 3, but it's never going to get there. As I zoom in, you can see the line is never getting to that 3. So that is one way that you can check if you're working these out correctly.